Good evening. Good evening, everyone. Yeah, not opening in webinar. Kanish, you're saying that is it a solo group? Yeah, I'll be confirming you regarding that. Okay. And actually, one more thing, we are having the sessions up to Wednesday. Okay, so don't worry. So usually we'll have another 2 to 3 sessions. In these 2 to 3 sessions, we'll confirm. Okay. Yeah. Good evening. Good evening, guys. Projects updates, please. Okay. Fine. So let me just share my screen just a moment. And in the meantime, everyone understood and also everyone has gone through the notebooks. And I think there was an assignment, right? There was an assignment, like it's your own self-paced, right? I just told you guys to just get a data set from SNS, from the Seaborn, and explore the data set I told you, right? Not as an assignment, Swasti, not exactly an assignment, but it's like a work, homework kind of a thing, which I told you, like for your better practice purpose, okay? For your practice purpose, I have told you guys to consider any dataset from the same one and do follow the same procedure and do implement all the pre-processing steps, okay? And also we can implement the models also, linear regression or logistic regression. We can implement those models also, as we are already done with these models, right? We are done with linear regression, logistic regression. So what today we will be doing is, yeah, that was done. That was done, correct. Okay, that was done. Fine. Okay, got it. Fine. So in between, I'll be asking few other questions in that case, everyone. Is it fine? Okay. So today we'll be discussing about decision tree and also random forest, which could take up to 30 minutes or 40 minutes. Then immediately we'll be going back to the notebook. We will build the linear regression model, logistic regression, decision tree, and a random forest. Okay. On the same data set, we will be building the same models. Okay. We'll be building those models, and if still time permits, we'll discuss about KNN. Okay. Fine. So let me just share my screen. Just give me a minute, guys. And if you're having any doubts related to the previous session, you may please ask me. So regarding the notes, Ritika, in the drive link, were you unable to see the handouts? See, regarding the project, Akshay, I told at the start of the session itself, right? So at the end of the last session, or else like on Monday and Wednesday, I will be giving update about everything. Okay, on Monday and also Wednesday, that is the upcoming week. I'll update you everything about these projects and all. Is it a solo or a group? Everything. Okay. Okay. So let me just share my screen. Okay. Just a moment. Okay, I hope everyone is able to see the screen. Okay, fine. So decision tree classification, okay? Decision tree classification. Now we will be discussing about this decision tree classification. How many of you are aware of this decision tree? See, decision tree algorithm, it can be used for both regression and also classification, okay? We can use this algorithm for both regression and also classification. And how we can use that we'll be seeing, and why it was named as a decision tree, we'll see, okay? First, decision tree. Okay, so decision tree is nothing but let's imagine this the tree structure. Okay, let's imagine a tree structure where each and every tree which we know will be having the what will be having the nodes. I mean the root, right? It will be having the roots and it will have the stem and the branches and the leaves, right? Leaf, roots, stem, branches, correct? So in a similar way, how a tree is having all those root and also leaves and also the stem, in a similar format here, in decision tree algorithm, okay, decision tree algorithm also, it will be inverted. It will be starting from roots, okay. It will start from roots and it will also have a leaf. See, here it will be the root node and these are the leaf nodes. Node, okay? Root node and leaf node, okay? Root node and leaf node, remember, okay? So what exactly happens in decision tree? This is like a tree like a structure, right? So even if you see decision tree means it follows a tree like a structure, starting from the root node to leaf node. Okay, we will be saying them as nodes. So it's like a tree like a model which will split the data, okay? It will split the data into subsets based on the feature values. We'll split the data into subsets, okay? Subsets on the based on the feature values. What feature values? Features are nothing but the whatever the columns or whatever the labels that we are having, those values, okay? And this decision tree can be used for both classification and regression. Okay. So remember, what are the two main important nodes here? Root node and the leaf node, okay? Now I'll explain clearly how exactly the decision tree works, okay? I mean the workflow logic in overview format first I will explain, then we'll go deep into the topic, okay? Then we'll go deep into the topic. Fine. So in a decision tree, we'll have a root node. And what does this root node do? Root node is nothing but it's a topmost node, okay? It is the topmost node in the tree. So it will be over here, the main node. Okay, that will be the root node. Okay, which will represent the entire data set. Okay, entire data set. Root node is present at the topmost and it is a very topmost node. It will represent the entire data set. Okay, it will represent the entire data set, and from the root node only the splitting will be happening. What kind of splitting? Splitting is nothing but it's a process of dividing the data into subsets. Okay, we'll divide the data into subsets. How? Based on, we'll be classifying based on the categories or based on the feature values we'll be classifying. Okay, like, okay, but what is this feature values and how we will be classifying? First we need to know that, right? So just a moment. Yeah, see this. We'll just go through this and we'll go for that. Okay, so what it is saying, supervised learning machine learning algorithm partitions the feature space into segments or regions based on the series of binary decisions. See, based on the series of binary decisions is either it go for 0 or either it would go for 1. So based on this binary decision, okay, the divisions will be happening. The partitions will be happening. Okay, so based on the binary series or binary decisions only, the partitions will be happening. Or it could be related to any segments or else regions. Okay, segments or regions. Okay, based on all these categories only, the partitions will be happening. So a root node which is present on the top of a tree or else the first topmost node, okay, topmost node will represent the entire data set, topmost node. And now what exactly happens is from the topmost node, the splitting will be happening. Okay, the splits will be happening, and these splittings will be happening based on the regions and also series of binary decisions. Binary decisions, it could be either that or this, like yes or no, like 0 or 1. Okay, and each branch will represent the outcome of that particular decision. Okay, whatever the branch, so it will be dividing into subsets, right? Those subsets are called as a branch, and that branch outcome will decide the decision. Okay, branch will represent the outcome of the decision. Okay, and then the leaf node, what is this? Leaf node will represent the final classification or regression output. Okay, let me just open one more. I will want to make things clear. Open one more. Okay. And let me just share this full screen too. Okay. So we'll discuss about this decision tree and random forest. Okay. Fine. Decision tree, random forest. Okay. Now, what are all the three main important components which we have covered until now? What are the three important names which we have been hearing in the past 5 to 10 minutes? Decision tree, and top of the topmost node is nothing but the root node. Correct. The topmost node is root node, and the second node is nothing but it's a branch, or else we can consider as a branch node, and followed by we are having what? We are having a leaf node. Okay, followed by we are having a leaf node. So root node, branch node, and leaf node. These are all the three different nodes. Based on these three nodes only, the decision will be happening. But what kind of decision will be happening? Now we'll see. Okay, what kind of decision will happen? Fine. So the root node will be the entire data set, and based on the decision of this particular, let's consider what was the example in the PPT. We'll consider the same example. Okay. Yeah, outlook. Whether the outlook is overcast. Yes, if it is overcast, what kind of sunny or rain? It is sunny. So sunny means humid. Yes or no? Yes. Okay. High or normal? How the humid is? High, normal. And if the overcast is for rain, let me just copy this. Okay, we're still having the slides here. Fine, here, see. So if the overcast is here, if it rains, and is there any wind involved? Yes or no? Okay. So if the wind is involved, so then it will be weak. So it is similar like we deciding to going and playing outside with our friends during our summer times or else during any other time during evening time. Okay. So it's like go out or else play. Okay, play we can consider as a root node, for example, and yes or no, and there will be two options, yes or no. Yes means there will be one kind of option available. What it will be available? Go out, like outdoor game, indoor game. Correct. Indoor games. Even in this outdoor game and indoor game also we'll be having different types. Outdoor game means how is the weather? Again, we'll be going for weather. Correct. So now what we are doing, this is the main feature or the main column which we are considering, and these other columns are the subsets. Based on these values, this value will be decided, okay? Based on these values, these subsets will be formed. The subsets will be formed, and even in this also we'll have some subsets. So from all the subsets, we'll have one node. That node is leaf node, okay? Leaf node. Leaf node. That node is a leaf node. Leaf node, what is leaf node here? Leaf node will tell us about what? Leaf node is like, it will be representing the class or the label. Okay. It will be representing the class or the label. If you see over here, see, leaf node represents the final classification or regression output. Okay. So how the entire process is happening? First, initially, it will start at the root node. Okay, root node is nothing but begins with the entire data set, and it will split the data. How it will split the data? It will initially choose a feature and split the data into subsets. Okay, but now you may get it out like how it will be choosing that particular topmost root node. That we'll see. Okay, that we'll see. But first, we'll understand the workflow. So it will choose a root node, and based on that root node only, the splittings will be happening. I mean, the data will be divided into subsets because from the root node only we have entire data. And then we have a recursively split, okay? Continuous splitting, okay? We have this continuous splitting process, or else we'll say recursive splitting, where the continuous splitting happens for the whole data until a stop criteria is met, okay? Until a stop criteria met. Then it will predict the class label. Okay, simple 4 steps process. Root node is nothing but a column, and from that column only the subset columns will appear. Subset columns will appear, and this splitting process will happen recursively, and until a stopping criteria is met. Then whatever the last node which we are having, that we'll call as a leaf node, and that leaf node will predict the class label. Okay, fine. So we'll just see about this human decision making, decision classification and regression, advantage, disadvantage, math. Okay, fine. So this is a human decision making. Outlook. So outlook overcast. If it is sunny, okay, fine. If is there any humid over there? Yes. I mean high or normal. If humid is present. So similarly, rain. Okay, is there any wind? If wind is yes, if the wind weak, if there is no wind, or else is it strong, weak or strong kind of. Yes or no? Binary. Okay, fine. So this is a table for regression and classification. Okay. Regression and classification. This is a table. Spec regression trees, classification trees. These are the specs. Okay. Like what are all the different specifications we can consider for decision tree. So if you're talking about the output, regression trees predict continuous numerical values. So regression means we all know regression is used when our target column is continuous, correct? So now coming into this classification, we all know it will predict the categorical class labels. So similarly, we are having this target variable type. Is it continuous or discrete? So regression trees will always have a continuous, correct? The target variable will be continuous in regression. Whereas in classification, it is discrete, okay? Discrete in the sense, either it could be a binary or else we can have a 3 to 4 labels also. Okay, 3 to 4 labels in the sense what? So let's say type of a car is the target variable. Okay, type of a car is the target variable. So how many types of car we can have? I mean, we will see nowadays sedan, hatchback, SUV, mini SUV, correct? So that is the reason the target variable could be a discrete. Okay, coming into objective. Why regression trees are used to minimize the mean square error? We'll discuss about this. Okay, we'll discuss about this mean square error and also Gini impurity entropy. Okay, splitting criteria also we need to discuss. Visualization, example algorithm, prediction mechanism. Okay. So in order to understand all this gain, impurity, entropy, we need to know first what is MSE or MSE, okay? And also the decision tree calculations also. But first we'll discuss this. It will be better in that case. Advantage, disadvantages. Fine. Okay. Understood an overview? Overview of what exactly this is? How exactly decision tree works? Understood an overview explanation? Yeah, root node I will explain, Akash. That is what I am saying, right? Okay, fine. So we'll start with this regression evaluation metrics. Okay, we'll start with regression evaluation metrics. Okay. So both in classification and regression, we are having some evaluation metrics. Why evaluation metrics? Evaluation metrics are used to evaluate the model. Okay, every model will give some output, but if the given output is fine, or else we can proceed with the model or not, those things will be divided by the evaluation only. Okay, and to do that, in this regression, we are having R squared. First one is R squared. R squared. So what is R squared? R square is nothing but it will measure how close the data is to the regression line. See, regression line is just a minute. Yeah. So if this is the plot, okay, if this is the plot, these are all the data points, okay, these are all the data points. There will be a best fit line, right? That will try to connect all the data points. So if this is the line, so that one is the regression line, okay? So this is the regression line and these are all the data points. So R2, I mean R square will be measuring how close a data point is to the regression line, okay? How close a data point is to that particular regression line. So as this is a regression line, let's consider this one as a new data point. It will measure the distance between the data point and that particular regression line, okay? And why exactly it will be doing that? To interpret the model, okay? To interpret the model. To interpret the model, we'll be doing that. So R square is nothing but the coefficient of determination, okay? Coefficient of determination. There is a formula also. First, let me write formula. R square is nothing but coefficient of determination. Determination, where we will be comparing the distance between the actual and the predicted sum of squares, okay? Predicted sum of squares by actual and also the mean of actual values. According to the formula I'm saying, it will be a bit confusing. So it will be 1 minus sigma yi minus yi cap whole square by, so again it will be sigma yi, okay, minus ym whole square, okay. So this is the formula for R2. R2 will be saying, R2 score will say, R square will be saying, okay. But remember what R square does. R square will measure how close the data is to the regression line. Okay? How close the data is to the regression line. In this, if we are getting the R2 score low, okay, the possible reasons for R square, the R square value is low, possible reason could be incorrect model or else irrelevant predictions, or else if you are having outliers, the R2 score will be very low. Okay. And if you are having R2 score very low, we can try different models. We can do the feature engineering. All those things we can do. Okay. So R2 score is nothing but, or else R square is nothing but, it will measure the data point with the regression line, okay, where the actual and the predicted values. What is yi? Yi is nothing but the actual value. Y cap is nothing but, yi cap is nothing but, this is I again, okay, yi cap is nothing but the predicted values, okay, predicted. So it is like actual minus predicted whole square by mod. Again, it's the same, but we are having the m value also here, okay. M is nothing but the mean of the actual values, okay. M is nothing but mean of actual values. Let me just write here. Yi is actual, yi cap is pred. We'll be saying pred for predictions, okay. Pred, and y of m is nothing but mean of actual, okay. Mean of actual. Fine. So with these values only, we'll be measuring how the data point is to that regression line. Okay. So this is about R2 score. And I told the possible reasons also, right? So if R2 score is less, I mean it is low, R2 score is low, then it will be, what are the things we need to consider? Either it could be the incorrect model which we are using for the data, okay, incorrect model, or else we can consider exploring, like if we can explore, the solution is we can explore different models, okay. Solution is we can explore different models, but the reason could be incorrect model or else irrelevant predictions, or else we can say outliers also, okay. So linear outliers, we need to make sure that we are removing the outliers also. And did I share the notebook with you? There is one notebook related to insurance data. Let me know if I shared the notebook or not. And regarding these particular handouts, I will share, okay. So first one, R square is done, right? R square is done. Understood R square, everyone? Yeah, Y cap is predicted, okay. Y cap is predicted. The voice is breaking in between. It will be fine now. Okay. No, R square is used for regression predictions only, okay. Only for regression. And whatever the evaluation metrics which I am saying, they will be used only for regression purpose, okay. Regression purpose. Fine. So after R2 or R score, we have MSE, okay. What is MSE here? MSE is nothing but where we'll consider all the observations, the actual and also the predicted values, and we'll calculate the MSE. MSE is nothing but mean square error, okay? Mean square error. Let me just write the formula here. So it's sigma yi is actual and yi cap is nothing but the predicted whole square by n. So that means yi actual, yi cap is predicted and n is the total number of observations. And what does this mean square? It will measure the average squared difference, okay? See here we are doing the square, right? So it will measure the average squared difference between predicted and the actual values. Let me just write. Average squared diff between predicted and actual, okay? Between predicted and actual, average squared difference between predicted and actual, okay? And if you are having low MSC values, it will indicate the better fit, okay? Low MSE value means, let me just, MSE should be low only. MSE is low, then what happens? It indicates the better fit between predicted and the actual values. Okay, better fit between predicted and the actual values. And if MSE is high, it will indicate the poor fit. Poor fit in the sense, like we need to make sure we need to again recheck our data. We need to do the feature engineering because MSE should be low. Okay, MSE should be low. Okay. And what exactly MSC is doing over here? It is penalizing the large errors. Okay, it will penalize the large errors. And one of the main disadvantages of this MSC is it is very sensitive to outliers. Okay, it is very sensitive to outliers. So this R square and also MSC we can use only while doing the regression problems. Okay, we're doing the regression problems. So as MSC, we are also having this RMSC. Okay, RMSC. RMSE. What is this RMSE? MSE is nothing but mean square error. So RMSE is nothing but it's like root mean square error. So square root MSE. That's it. Okay, square root MSE. So what RMSE will be doing? See, MSE means we know actual and the predicted average difference we will be getting. So that average difference value we will be getting under root of that particular value. Okay. In RMSE, it will give the error values in same units, okay? Same units of the data. To get the value or the output in the same units of the data, we'll be applying root. If we apply if we apply MSE, we'll not get the output in the same units. But if we apply RMSE, we'll get the output in the format of same units, like how our data is, okay? Which will help us to understand the error also, okay? Which will help us to understand the error also. So that is the main difference between RMSE and MSE, okay? We are having this MAE also, mean absolute error. So what exactly mean absolute error does? It will find the difference between the actual and predicted only, but it will find the absolute difference. Absolute difference it will find. Absolute difference in the sense, it will apply the mod, okay? It will apply the mod. The formula will be, it will be like 1 by n sigma here, starting from I to I1 to n, then comes the modulus yi minus yi cap. So modulus means even if there is a negative value as an outcome, it will just return the value only, correct? It will just return the value. So these are all the regression metrics. MAE, RMSE, MSE are the regression metrics, okay? And also R square. R square is the regression metrics. And remember, linear regression is very sensitive to outliers, okay? So these are all the regression metrics. If you're having doubt or else you want me to repeat, let me know. Yes, correct. Low R2 score, it leads to poor performance. Low MSE, a better accuracy. Right. MAE formula, yeah, this is a formula. You're seeing, right? 1 by n sigma I equals to 1 to n modulus of, we'll be applying that mod, okay, that's it. So why we are applying that mod? To get the absolute values. Because absolute values in the sense, even if that output value is negative, we'll get that value only. It will not show it as a negative. That's it. Understood, right? Like R square, MSC, RMSC, ME. Anyone, any doubts? Am I audible? Any doubts, anyone? Okay, fine. Okay. Okay, fine. So I see no one is saying any, so no one is having any doubts, right? So, see, okay, good one. So one of your friend is asking like, where do we need to apply these formulas? Okay. See, it's for our understanding purpose. The formulas are our understanding purpose. Okay, for understanding purpose only. While implementing the code, we just need to call the R2 square or else call MSC, RMSC. So inside all the calculations will be happening and it will return a score. Okay, it will return a score. But how the calculations are happening based on these formulas only. Okay, based on these formulas only. Yes, the notes will be provided. Okay, don't worry. Fine. So we'll start with the classification matrix. But before going into the classification matrix, I'll just draw the confusion matrix table here. Okay, draw the confusion matrix table here. And I just want everyone to just go through the table, okay? Confusion matrix, okay? Confusion matrix. So what exactly confusion matrix? Anyone is aware of this confusion matrix? In this confusion matrix, we'll have actual and predicted, okay? Actual and the predicted values we'll be having. Where, so let's say I need to draw the confusion table, right? So this is, so row wise, if you see column wise, it's actual. If you see row wise, it is predicted, okay? So just write actual. In the actual, we'll have actual positive and actual negative we'll have, okay? Actual positive and actual negative we'll have. And for the predicted, we'll also have the same, okay? Predicted positive, predicted negative we'll have. Predict positive, predict negative, okay? Predict negative. So based on these values only, let me just write it clearly. Positive, negative, okay? Positive, negative. So these are all the actual existing values, okay? These are all the predicted values from the actual, okay? Actual. So if the actual value is positive and the predicted value is also positive, we'll call it as a true positive, okay? We'll call it as true positive. And if the actual value is positive and if the predicted value is negative, we'll say it as false negative, okay? False negative. So here if you see again actually is negative, but predicted is positive. So actually it is negative, but it is predicting it as positive. Then it will be false false positive. Okay, then it will be false positive. And if actually is negative and predicted is also negative, then it is true negative. Okay, true negative. How many of you are aware of this particular confusion matrix table? Yeah, true positive, true negative kind of a thing. Correct. Everyone aware of this or else? Just go through the table, okay? Just go through the table. In the meantime, I'll just look if there is any image reference for this explanation purpose, okay? Just give me a minute. Just go through the table. So this is an actual values. This is the predicted values. In the actual, we have positive and negative values. Actually, that value is positive. Actually, that value is negative. And in the predicted also, we are having positive and negative. It is predicted as positive. It is predicted as negative. So when a positive overcome, it will be true positive. So actually, the value is negative and the predicted is positive. Then it will be negative. Then comes a positive. So false positive. It is positive. But in the actual, again, it will be positive and it will be negative. So it is false negative. Okay. Just go through this confusion matrix table. Just a moment. Okay. So actual and the predicted values. Anyone have gone through this? Or anyone ever heard of this? Okay, fine. Now we'll discuss what exactly this TP, FP, FN, TN. Okay. And everyone understood how we got the TP, FN, FP? See, what we need to consider is on the top we'll have the actual values. Okay. Actual values we'll have. So for these actual values, whatever the actual values will have positively predicted values, negatively negative values. Okay, I mean actual and predict. Fine. We'll write here predictions. Okay, predictions. So for this, for every prediction, and we'll have the actual values, right? For every prediction, we'll have an actual values. So now we will be checking if that predicted value is being predicted correctly or not. Okay, let's say actual value is S. If the predicted prediction or else if the predicted value or else in prediction, are we getting yes or not, is what the confusion matrix is. Okay, is what the confusion matrix is. In the actual, we'll have the positive negatives. And for the prediction also, we'll have the positive negatives. Okay. Negative. So just a minute. Yeah, positive negatives. Okay. So now if it is actually positive, okay, the value is actually positive and it is also predicting positive. So let's say that value is 1 and in the prediction also we are getting the 1. So what this one will be, it will be, what it will be, see if you see over here, where was the diagram? It will be true positive, okay, it will be true positive in that case, okay, true positive. And now if the actual value is positive and it is being predicted as negative, okay, actual value is positive and being predicted as negative, then it will be false negative, okay, false negative. And where the actual value is negative and it is predicting as positive, okay, the actual value is negative but it is predicting it as positive, then that in that case it will be false positive, okay. And where actual is negative and also predicting negative, so everything is true, correct, so true negatives, okay, true negative. So this is what the confusion matrix table is, and we are having terms also. TP is true positive, FP is nothing but the false positive, okay, FN is nothing but the false negative, and we also have T and TN is nothing but the true negative. So first we'll start with the TP. What is TP? TP is nothing but the correctly predicted positive instances, okay, correctly predicted positive instances. We are having FP. FP is nothing but incorrectly predicted positive instances, okay, incorrectly. This is correctly predicted positive instances. This is incorrectly predicted positive instances. Incorrectly in the sense which are already negative, which are already negative, but the prediction is positive, but it should be negative. Correct. So they were incorrectly predicted. And similarly, we have this false negative where they were incorrectly predicted as negative, but they were actually positive. They were incorrectly predicted as negative, but actually they were positive. Okay, actually they are positive. And true negative, we all know, correctly predicted negative instances. See, simple guys. We'll consider TP and TN now. TP is true positive. TN is true negative. TP is true positive. True positive is it is true. The actual value is true. Okay, and the predicted is also true. Okay, whatever the use case that we are considering, the actual is true, predicted is also true. Then we'll say it as correctly predicted positive instances. Okay, correctly predicted positive instances. And TN is nothing but true negative. True negative is correctly predicted negative instances. TP is positive, TN is negative. These two, TP and TN, refers to correctly predicted positive and negative instances. Okay, positive and negative instances. Then we are having this false positive and false negative. What is false positive and false negative? See, false positive is nothing but incorrectly predicted positive instances. Okay, in that case, here in this false positive, the actual value will be negative. Okay, actual value will be negative, but it is predicted as positive. Okay, actual value is negative. The actual value is negative, but predicted as positive. In what? In FP. FP is false positive, which are actually negative. The values are negative, but they were being predicted as positive. That is wrong, right? So we'll say it as a false positive. Okay. Then we are having false negative. What is false negative? They were actually positive. Okay, they were actually positive, but they were being predicted as negative. Okay, they are being predicted as negative. So that is what a false negative is. I hope this false positive, true positive, false negative, true negative are clear. Confusion matrix, everyone. I'll give examples also, okay? I'll just give examples also. Is it clear? Clear? Yeah, we'll be going through that. Okay, we'll go through that accuracy, specificity, sensitivity. Okay, but first we need to understand what are actual values. Based on these true positive, false negative, and true negative values only, we will get the accuracy, specificity, sensitivity, F1 score. Okay. Okay, fine. So let's have a short break. Okay, let's have a short break. After that, we'll discuss clearly about this classification metrics. Then only we'll move forward with decision tree. Okay, let's have a short break. Okay, hope everyone is back from the break, right? Fine. So we'll discuss about that classification matrix, okay? We'll discuss regarding the classification matrix. Fine. So I hope everyone understood this true positive, false negative, and true negative, right? So now based on those true positive, false negative, and true positive, I mean true negative, on those values only, I mean on that particular confusion matrix table only, we're having few classification metrics. Okay, we have few classification metrics like we're having precision, recall, F1 score, accuracy, specificity, sensitivity. We consider. Okay, fine. So in anyone know like what exactly the accuracy is over here in classification? Fine, I'll just proceed. Okay, I'll just proceed. First one we'll go with this precision. Okay, precision. All these are classification metrics. Okay, first one is precision. But why precision? When do we need to consider the output of precision? We'll see. Okay, the definition, the formula, and along with an example, we'll see for each and every metric. First one is precision. Precision means it is the proportion of all the positives. Okay, all the true positive among all the positive predictions. So the formula will be for precision. The formula is true positive by true positive plus false positive. Okay, this is the formula for precision. So what is true positive? True positive is nothing but it is correctly predicted positive instances. Correct. What is false positive? Incorrectly predicted positive instances. Okay, so either way we are considering all the positive instances only. Correct. So it is a proportion of true positives, actual true positives among all the instances. Okay, actual true positive among all the instances. If we say like this, you'll just understand all the true positive values only in precision. Correct. But I'll just explain with one example. Okay. So let's say in a class there were students and there were around 100 students. Okay. 100 students who actually passed the test. Okay. 100 students have cleared that particular test. So they were under this particular category pass. Correct. But the model is predicting EIT of them correctly. Okay. The model predicts only EIT. Instead of 100 students, only 80 students were cleared by the model because the model is only predicting 80 people have cleared that particular test. So, sorry, just set it in reverse format. Just a moment. Just write it clearly. So it's like precision, correct? True positives, positive, fine. So it will be like model will be predicting 100 students as pass. Okay, the model will predict as 100 students as pass, but actually only 80%. Okay, in actual scenario only 80% of members have cleared it. Okay, actually 80% of the members have cleared it. So how the calculations happens here? True positive by true positive plus false positive. Okay, so 80 of them have actually passed. Okay, and again 80 is 80 only. So what is false positive? Model is predicting how many? Model is what it is doing? It is false positive. Right? What is false positive here? False positive is incorrectly predicted positive instances. How many incorrectly predicted positive instances we are having? In total 100, the correctly predicted are, I mean the actual are 80. The model is telling 100. How many incorrect predictions it is doing? 20. See, actual people pass is 80. Model is telling 100. So how many students Actually, it's making mistake for what is the difference? 20 is the difference. So here it will go 20, okay? Here we'll have 20. So we'll accurately get what? We'll get around 0.8, right? 0.8 percentage. So the precision, how precisely the model is predicting? Model is predicting up to 80% of predictions correctly. The model precision is 80% correct. Understood precision? Understood precision? See, I'll just explain precision once again. What the model is doing, see, what is 80 here? 80 is true positive. 80 is true positive. And how we got 20? See, the model is predicting 100 students have cleared the exam. But actually, what happened was only 80 people has cleared. The model is wrongly predicting 20 people. So that 20 will come under false positive, okay? 20 will come under false positive. So in that case, 80 by 80 plus 20. So 80 by 100. So we'll get around 0.8, right? So 80%. 80% of predictions are correct in precision. Okay. If you are using a student data and if you want to calculate the precision, so we got 80%. Okay. Clear precision? Is precision clear? Everyone? I see only few people answering all the time. What happened to others, guys? Others, Aditi, Aditya, Akash, Akash Deep Maurya, Akshay, Aman. So all the persons alphabet letter A, please respond. Okay, fine. Okay. So Akash, you're saying that my voice was breaking, right? So for others, I think it's fine. So please check the internet connection from your end. How? Okay. So one of the question was, what does the precision mean here? What does the precision mean here? Precision means like how precisely it is predicting the values. Okay, how the model is predicting the values. That's it. How the model is predicting the values. And what values? Only the positives. Only the positive instances we are considering. That's it. Okay, only the positive instances we are considering here in the precision. Okay, fine. So next we can consider recall. Okay, recall. What is recall? For recall also we are having a definition. We'll consider that formula. We will go through an example also. Okay. So what is recall? Recall is nothing but it is also a proportion of true positives among the actual positive instances. Okay. Same proportion of true positives among actual positive instances. We'll consider the actual positive instances over here in the recall. But in the precision we are considering among all the positive instances. Okay. In the precision, see the precision, the difference is it is a proportion of true positives among all positive predictions. Okay, all the positive predictions will consider. But in recall, it is a proportion of true positives among all the actual positive instances. We'll consider all the actual positive instances over here. Okay. So let's write the formula over here for recall true positive by true positive plus false negative. Okay. True positive by true positive plus false negative. So what is true positive? We all know all the positive instances, but here we got instead of false positive, we got false negative. What is false negative? Incorrectly predicted negative instances. Okay, incorrectly predicted negative instances, which are actually positive, but they were being predicted negative. That's it. Okay. So the example you can consider for recall is, so we'll consider the same example. So suppose there are 100 students who actually pass, okay? 100 students clear the exam, but model is saying 80% has cleared, okay? Only 80 people has cleared, okay? So now what we will be doing as per the recall formula. So all the 100 is, the actual is this, the predicted is this, predicted actual. So true positive is all the positive instances which are all actually positive. So 100 by, sorry, recall, right? It will be 80 by, okay? So this is what the formula is. Because why? I mean, this is how the values will be. This is how the values will be. Why? Because here they are considering the true positives and also the actual positive instances, okay? Which are actually positive instances and also the predicted positive instances we are considering. And we are calculating the recall. And after this recall, we have F1 score, okay? F1 score. So everyone know the harmonic mean? Harmonic mean. What is harmonic mean? Harmonic mean, arithmetic mean, reciprocals. Remember? Okay. So in F1 score, we will consider the harmonic mean of, what? So precision and recall. Okay, precision and recall will consider the harmonic mean. So what is the formula for this? F1 score is 2 into, okay, 2 into precision into recall by precision plus recall. Okay. So whatever the precision calculation which we are doing, whatever the recall calculation which we are doing, by adding those values and also by getting the product of those values where we are multiplying it by 2, then we'll get this F1 score. Okay, then we'll get the F1 score. F1 score is nothing but the mean of precision and recall, harmonic mean. Okay. So example we can consider is, suppose precision is 0.8 and F1 score is, precision is 0.8 and recall is also 0.8. So you can calculate based on these two values. You can calculate the F1. Okay, F1. And also followed by we have accuracy. Accuracy. So what is this accuracy? All the correctly classified instances will present in accuracy. Okay. All correct values will present in this accuracy. So accuracy formula is true positive plus true negative by true positive plus true negative plus false positive plus false negative. Okay. So this is the formula for accuracy. We'll consider all the true positive and the true negative instances by all the instances. Okay. All proportion of all the instances. So example you can consider is, if a model is predicting 80 true labels, okay, 80 true positives, 90 true negatives, 20 false positive, or else you can consider 10 false negatives, you can calculate the accuracy. So how many values are these? How many values are these? And how many of these values are present? Based on this, we'll consider the accuracy. Okay. But accuracy will be seeing mainly. Okay, we'll be seeing mainly for normal basic classifications. But if you go for precision and recall, we'll specifically use as per the use case. Okay, we'll specifically use as per the use case. We also have a specificity and sensitivity also we have. But clear until accuracy? Okay, I see. Isn't it sensitivity? Sensitivity for what you're saying? Okay. So where did I write R actually? No, I haven't written any R. Yeah, this R is recall, okay? Recall. Precision and recall. Sorry. The R was precision and recall, guys. The R was precision and recall. And for recall, we can also call it sensitivity, okay? Yeah. Recall, we can also call it sensitivity. Any doubts? No doubts, right? Clear? Up to accuracy. Accuracy, precision, recall, F1 score. Recall is nothing but sensitivity. We'll also see the specificity, okay? So first, accuracy. When to use this accuracy, okay? No. Akash, in the last 10 minutes, we'll be discussing about the handouts, right? Okay, so got it. I see only Akash asking regarding these handouts and also regarding the recordings and all. Akash, please. Okay. In the first 10 and the last 10 minutes, okay? Fine. So now I will say like when to use what metric, okay? When to use what metric? Accuracy. When to use accuracy? When the classes are completely balanced, okay? When the classes are completely balanced means, let's say I'm having a target variable like approved, loan approved or not, okay? Loan approved or else let's say, let's consider any other column, like an S or no type of a column I'm having, okay? Let's consider S or no type of a column I'm having. So for that, if I'm having 500 values for S and around 450 or else 500 or else 550 values for no, then we can consider them as the classes are balanced, okay? We can consider the classes are balanced. So they the cost of misclassification is same for all the classes, okay? So there will not be any misclassification because all the classes are balanced. Okay, precision. Now we'll go for the precision. When to use precision? So the cost of all the okay, okay. Fine. I see a few people are boxing. Fine. Okay, see when to use precision, okay? Precision when to use when we want to minimize all the false alarms, okay? When we want to minimize all the false alarms, we can go for precision. Okay. Like predicting, I mean, this is a famous example. I hope you all heard of this example. It's like predicting whether the patient is having a disease or not, okay? Where the false positive can lead to unnecessary treatment, okay? Correct or not? That patient, if that particular patient is not having any disease, and if the model is predicting that patient is having a disease, so it will lead to unnecessary treatment, correct? So in those kind of scenarios, if you're dealing with the medical data or else any sensitive data, we can go for this precision, okay? I mean, sensitivity is for recall, but if you are dealing with those kind of domains, we can go for precision. And in recall, you can consider the example as when we are predicting any customer, okay? When we are predicting any customer will churn or not, okay? Churn in the sense, like, will he be able to repay the loan amount or not? Based on all his details, we'll be assessing our friends or else any loan approval officer, how he will approve the loan. We'll check all our assets. He'll check what are we studying. He will be considering all our other source of incomes also, and then he will be deciding whether he will be able to pay the loan or not. Correct. So in those kind of scenarios, we'll go for recall. Okay, we'll go for recall because if we fail to predict, and approve a loan for a person, what happens? The person may use all the loan and he won't be able to pay the loan also. Then in that case, it's all fault by the model, right? It's all fault by the model. So we need to make sure that we are using recall over here. Okay, we are using recall over here. And F1 score. F1 score, it's like when we can use F1 score when predicting about the weather. Okay, like whether a product review is positive or negative. Okay, if you want to know about a product and if you want to know if that review is positive or negative, we can go for both precision and recall, which includes both precision and recall. Okay, and there is this another topic called specificity. Okay, specificity. What is specificity? When we want to measure the proportion of all the negative among all the negative instances. Okay, I want all the negative values among all actual negative values. Okay, it was predicted as negative, but I also want to consider all the actual negative values. So the example you can consider is, it's like predicting a person, like predicting whether a person is disease free or not. Okay, predicting whether a person is having a disease or not, because this specificity will allow us to measure the ability to correctly identify all the healthy individuals. Okay, so this is about the specificity, sensitivity. Sensitivity is nothing but again recall, accuracy, precision. Okay, and also F1 score. So this is about all these metrics. And one more thing. So all these metrics are fine, but one more thing. When to choose which metric? Okay, when to choose which metric? Three things you can consider. Okay, three things you need to consider while choosing a metric, or else while coming to a conclusion. First one is you need to consider the problem type. Okay, you need to consider the problem type. What kind of problem are we trying to solve? Is it a binary or else a multi-class classification? Okay, that is one thing. And class balance. Okay, we need to consider the class balance also. If the class is completely balanced or imbalanced. Okay, and we need to consider the cost of misclassification. Okay, misclassification. Misclassification means not correctly classified. Different costs for false positive and false negatives. Okay, so these are all the metrics you need to consider: the problem type, the class balance, and the cost of misclassification. These are the three different metrics you need to consider when you are dealing with this specificity, F1 score, recall, precision, and accuracy. Okay, and a detailed handout will be provided. Okay, fine. Okay, see two queries, class bias and also specificity again. So first I will continue with this specificity so that everything will be clear. Then I will explain what is class bias. Okay. Specificity is like when we want to measure the true negatives. Okay, true negatives among all the actual negative instances. Okay, among all the actual negative instances. Let me just write over here. It will be better, I think. Yeah. Specificity, right? Fine. All the negative instances among the actual negative. All the negative in the sense predicted negative instances among the actual negative instances. The formula will be true negative by true negative plus false positive. Okay. This is the formula for specificity. The main focus of specificity is correctly identifying the negative instances. Negative instances. To identify only negative instances, to correctly identify how many negative instances I'm having, I can use specificity. So, predicted true negatives by predicted true negatives plus actual negative instances. That's it. Okay. Actual negative instances. That is specificity. So, specificity will focus on identifying negative instances. Sensitivity will focus on identifying the positive instances. Sensitivity is recall. Okay. Clear? Clear, Sharma? Okay, so like in the very first go, mostly it will be a bit confusing, but try to go through the handouts and mostly I'll be uploading the handouts. Okay. So handouts, I should not see any queries about handouts. I mean, in today's session. And coming into class bias, I need to explain class bias, right? Fine. Okay, so yesterday, what was the data set that we are dealing with? What was the data set? Iris, right? Iris is the data set. So in this Iris data set, what is our classification? I mean, what is our target variable? Species, right? Species. In the species, what kind of species we are having? We are having Setosa, virginica. Okay, let's consider I'm having Setosa and virginica only. Okay. So I'm having total 1,000 rows. Consider I'm having total 1,000 rows. The shape of my data set is 1,000 rows and some columns, some X columns, where one of the column is species, and for the species that is the target variable, where it is having two values, Setosa and virginica. Okay, where it is having two values, Setosa and virginica. So as my target variable is having only two values, so all these 100 rows will either belong to Setosa or else virginica, correct? All the 1,000 rows will either identify a Setosa or else it will identify a virginica, correct? So let's say the Setosa is having only 490, okay? 490. So how many will go for virginica? 510? 510 will go for virginica, correct? So if there is a slight difference between, so 10 values, so 10 samples are extra for virginica, 10 samples are low for Setosa, correct? Setosa is having only 10 less samples when compared with virginica. Virginica is having 10 more samples, correct? 10 more samples virginica is having. Now, this one is good. This one we'll call it as balance, okay? Sorry. Balanced data set, okay? Balance, because we are having ample amount of samples for Setosa and virginica in order to train our, not to train our model, okay? Not to train our model, we are having ample amount of samples. So for the same Setosa and virginica, let's say Setosa is having 300 and virginica is having 700, right? 700. So I'm having how many 700 virginica? 300 Setosa. Okay. Now if I build a model on this particular data, no matter the accuracy, my model will always tell it is Virginica only. Okay, my model will always tell, okay, the user is giving these values. It is Virginica. Even if the user is giving the values related to Setosa, also the model will predict it is Virginica only, because it has 700 plus values. I mean 700, around 700 values in Virginica, and only 300 values in Setosa. This kind of balance, or this kind of distribution is imbalance. Okay, imbalance data will say. Imbalance data will say. So that is what the class bias is actually. Okay, clear, Akash? Okay, fine, good one. So where do we need confusion matrix at all? See, when to consider this matrix, so that step only the classification or else this confusion matrix comes into picture. So what are the three main important factors I told? When to consider what? Three main important factors. When to choose what metric, and why confusion matrix is your question, correct? See, confusion matrix will help us to calculate the accuracy, how accurately the model is predicting. Okay, fine. So along with this accuracy, we are having some other metrics also. So we'll calculate all the metric scores initially, but based on what metric score I need to consider that model should be the question. Okay, let's say I'm having accuracy as 80. Okay, and I'm having this specificity as 60 and recall as, let's say, 70. Okay, recall as 70 and F1 score, let's say 65. So everything covered, right? Accuracy, specificity, precision, right? Precision, let's say I'm having 80. Okay, I'm having 80. But when I should consider accuracy, when I should consider specificity, when I should consider sensitivity or else recall, when I should consider F1, when I should consider precision. All these metrics will depend on type of the domain. Okay, the type of domain. Type of domain that we are dealing with. Domain in the sense, are we dealing with a medical data, or else are we dealing with a financial data, or are we dealing with a bank loan approval data? It depends, correct? So depending upon the domain, we'll go for recall, we'll go for specificity, we'll go for accuracy, we'll go for precision, we'll go for F1. Okay, clear? Clear? Okay. So Akash, is that clear? Akash Deep? Okay, thank you. So anyone having any queries in today's session? So Ali, notes link, right? Yeah, notes is nothing but, so notes you're talking about handouts, correct? Handouts I will upload, okay? Mostly by the end of the day I will upload. So yeah, there was a delay actually, but I will upload them, okay? Okay, fine. So any other queries, guys? No? Yes? No? Let me just keep a small poll and let me know over there, okay? Okay, Akshay. Fine, I'll inform, okay? I had just created a small poll, have you understood all the evaluation metrics and working of decision tree? Decision tree, we are not done completely, okay? We need to discuss about this entropy, all those factors we need to discuss. But the workflow, have you understood about decision tree? Let me know, okay? Please do the poll. And once you're done with the poll and not having any other queries, practical implementation of that next session. Okay, in the next session we'll discuss the decision tree, and we'll implement this linear regression, logistic regression, decision tree. Then only we will proceed with random forest. Okay. I see 2 no's. If you're having still any doubts, let me know. If it is related to handouts or notes, I will be uploading it. Okay. On Friday, actually. Okay, coding classes were not yet available. So up to how many sessions are still pending? How many sessions are still pending, excluding this session? Okay, around 2 sessions, correct? Around 2 sessions. No, next live session is on Monday. No, on Friday we'll be having a session. Okay. On Friday we'll have a session. Yeah. So the true positive, false negative, and all those things, but will come under the confusion matrix. So confusion matrix table. And coming into this evaluation matrix, based on this confusion matrix table only, the precision, recall, F1 score, specificity, sensitivity will be calculated. Okay. Fine. So if no one is having any other doubts, you may leave the session, guys. Thank you. Okay. Yeah. Thank you. Thank you, guys. Okay. So guys, if you're not understanding anything in the middle, just mention it. Just mention it. I'll go through all the chat and I'll just address that query. Okay. This Friday and next Friday. See, next Friday, no. But this Friday, let me just check. Just give me a minute. Let me just check and confirm. Okay. Okay, got it. So even Friday it is showing self page. Just a minute. So everyone is in the Telegram group, right? Everyone is in the Telegram group, correct? Yeah, I have just seen the calendar. I'm sorry. Okay. So I'll just confirm with the team. I'll just confirm with the operations team. Okay. And I'll give an update immediately by the end of the day. In the next 1 or 2 hours, I'll give that update. Okay. If you're actually having the session or not on Friday. Okay. Okay, guys? Fine. Thank you. Okay. Okay. Fine. So, thank you, guys. Thank you. Thanks for joining. Everyone may leave the session now. Thank you. Yeah. Thank you. I'm in the session now. Have your dinner.